So in our last video, we talked about link reaction, and today's video will be just, continuing the process of the link reaction. So previously we had pyruvates, or two of them, where there were 3 carbon molecules, and as it enters the mitochondria into the matrix, it loses the carbon and would produce 2 carbon dioxide, and this wouldn't be useful in this process. So we're left with 2 carbons, and that gives it the chance of the enzyme CoA to attach, and it will be called acetyl-CoA. While this also happens, it is being oxidized where it loses 2 of the hydrogens and would attach to the NAD that's been waiting for it, and will turn into NADH. And because of this being formed, it gives the oxaloacetate the chance to combine with the acetyl-CoA, and it's already in the matrix, so it's just waiting for it to combine. And the product of this would be citric acid. So in the end of the process, we would have 2 citric acid, and this is the process where it starts the Krebs cycle. Okay, so in the link reaction, we talked about how the 2-acetyl-CoA will combine with oxaloacetate and then create 2 citric acid. So in the start of the Krebs cycle, which happens in the matrix of the mitochondria, the 2 citric acids will go into decarboxylation, where they lose, each of them lose carbon, and because of that will create the product of 2 carbon dioxides. And that's oxidation. In reduction, the carbons will also lose electrons and hydrogens, and the NAD will get the hydrogens from that and create 2 NADH. And to continue, the citric acid will continue losing carbons and create another product of 2 carbon dioxides and 2 NADH. This one being oxidized and then this one being reduced because of the hydrogens being lost. To continue, ATP is created inside the mitochondria to create FADH, or FAD, which is more of like an upgraded version of NAD, and will capture more of the hydrogens from the citric acid along with the NAD, so it will also create 2 NADH after the reduction, and this being oxidized. And by the end of this, we will go back to 2 oxaloacetates, which will go back to the matrix of the mitochondria and produce more of a link reaction. This will happen 2 times depending on the citric acids that are being made. And the end product of the Krebs cycle would be 2 citric acids, 6 NADH, 2 FADH, and in the Krebs cycle there would be 2 CO2s, but in the link reaction we previously had 2 CO2, so 4 plus 2 would be 6. And in the last part of cellular respiration would be 6 water molecules, which we will explain in ETC, or the electron transport chain.